algebra tiles for integers, they ought to know that you have positive ones and you have negative ones. So the next thing I would do is introduce the next piece, which is an x. And I would say, okay, if I put an x up here, I ask my kids at their desk, and they have their own algebra tiles, to go ahead and tell me how long and how wide this x is. Because we'll take a look at the 1 and say, the reason this is called a 1 is it's got a length of 1, a width of 1, so therefore the area of it is 1 times 1, which is 1. So we name it 1 for that reason. So if we look at the x, we want to know what is its width and what is its length. So kids will say, okay, they'll start building it. They'll either try to put them on top or they'll put them underneath. And they'll see that it doesn't quite match down here. And so kids will say, well, you know, it's like 3 1/2 or 3 1/4 or whatever. I say, okay, well, we're for sure on the width of it. So what we have here when we have this particular tile is it's 1 wide. But we don't know how long it is, so we call that x because it's not known. So we say, okay, therefore, the area of this is 1 times x. So its name is 1x, or as some people just call it, x. So my area is 1x, or x, as my area of that is 1. Now once you've done that with the x, you can say to the kids, okay, now we're going to look at the large square. And how am I going to determine its length and width? Well, kids automatically are going to start putting the smaller squares next to it, because that's just what they do. They're trying to determine the width by doing that. But after a little while, when they find out that that doesn't work, most of them will say, well, okay, let's try something else. And so they will then put the x by the length and by the width. And so now what we have is we have a large square. We determine that the length of it is x, the width of it is x, so its area is x times x, or simply x squared. And so this is our x squared piece, we have an x piece, and we have a 1 piece. Now, once kids get a name to this, then you can do all kinds of things with them. For instance, I can teach some very important things in Algebra 1 to very young students who, my Algebra 1 students don't get it without the algebra tiles. If I say to them, I want to combine some things, so all I need to do is go ahead, put up my tiles, and say, okay, it says I have 2x squareds. It says I have 3x, any way I want to put them. And it says that I have 1, and I'm going to add to it 1x squared, 2 x's, and a 2. Then combining like terms to the kids is just counting, because that's all it is. So they add it all up, and they say, okay, well, what do I have? And they say, well, you have 3x squareds, you have 5 x's, and you have 3. And so right now they've combined like terms better than most Algebra 1 students will do it who haven't worked with the algebra tiles. Because it's a matter of when they see the shape, they're just counting. And so you can use this to do any kind of combining of like terms with the algebra tiles, with working with the x squareds, the x's, and the 1's. So if I want to change that just a little bit and say, okay, let's say I start off with the same 2x squared, the same 3x, and the 1. But let's say this time I want to add to it a negative x squared. And say I want to add to it negative 2x and a negative 2. Well, I can do that because all I need to do is put those pieces up here. So if I want to add to it a negative x squared, a negative 2x, and a negative 2, then if the kids have worked with the algebra tiles for the integers, then they realize that this is going to create a neutral here. That's going to get a neutral pair here. I've got a neutral pair here, and I have a neutral pair down here. And all I count is what's not neutral. So I end up with the fact that I have 1x squared, and I have 1x, and I have a negative 1 left over. And therefore, I have combined like terms. And the very nicest thing about using the algebra tiles is Students never tell me that they have 2x to the 4th. They don't get that exponent wrong because they know what the tiles looks like, and they know that these tiles are x squareds. And so therefore, when you combine them, then all they can get is whatever pieces they started out with in the first place. And so you save them from all kinds of hassles that kids usually do when they combine like terms. And like I said, you can use this with very young students because they can see what the pictures are. And the most important thing is, as long as the kids can use the tiles, they can do all kinds of creative things with them as far as learning just foundational algebra topics. The other thing is, once the kids have transferred the learning of the tiles to where the pictures are up in their brain, then they really don't need to have the tiles. And since that works for every student at a different pace, then you have to say, okay, I need to make sure my students have the algebra tiles available. But nice thing about it too is they don't have them available, they can always draw them. They can always say, okay, I know that this is 2x squared. And I know that this is 3x. And I know that I have 1 here. And then they can draw that negative x squared, know that that's going to neutralize out. They can draw in a negative 2x, know that that's going to neutralize out. And then they can draw in a negative 2 and realize that that's going to neutralize out and still come up with the same answer, even if they don't have the tiles. So if they're taking a test, standardized test, they can't use manipulatives, they can always draw it out if you have allowed them to use the tiles long enough. And so the whole concept of algebra tiles is just a really good way to start kids off with a visual understanding of mathematics.